that last confidence interval problem had the interval given to us, already built in StatCrunch, and we just had to read the output. But in this problem, it's not built for us, and we're going to have to do it all ourselves. All right, so a researcher for the CDC is interested in the difference in seatbelt usage rates between male and female drivers in the U.S. A random sample of 700 male drivers found that 84% of them wore their seatbelt, and a random sample of 600 female drivers found that 92% of them wore their seatbelts. All right, well, let's see here. We need the N for male. The sample size for male was 700. And the p hat for male is right here, right? So these go together. So this was 0.84. All right, the N for female was 600, and the p hat for female was 0.92. All right, now it wants us to find x, and it wants to give us whole numbers for x. Okay, so let's think about that for a second. P hat is x over n. We've known that for a long time. Right? If p hat is x over n, right, that's one formula we've learned. Then to solve this for x, you would multiply by n. So that means x would be p hat times n. So that's two lovely formulas, right? One really comes from the other. Okay, so this is going to help us to find our x values. And if you're thinking, why do I need my x values? You need them for the sake of putting that all in the StatCrunch later. So x would be equal to p hat times n. So it's the p hat for the males times the n for the males, which would be 0.84 times 700. So we got to find that number. And then we also want 0.92. So p hat for the females times n for the females. So I guess I'll put little f's next to these and little m's next to these. So we want 0.92 times 600. Okay, so let's go find those. And we need to round to the nearest whole number. Not fancy rounding, just regular or ordinary rounding. Oops, let me close these ones from before. Okay, so 700 times 0.84 is 588. So that one's already rounded. That's great. 600 times 0.92. Perfect. We didn't even need to round these. So we get 588 for x for the men, and we get 552 for x for the women. Wonderful. Now, before I go any further, I will say I'm going to need q hat down here. So I'm actually going to take a moment and find the q hat values. So q hat for the females would be 1 minus 0.92, which is 0.08. And then q hat for the men, I'm just going to put it up here. Q hat for the men would be 1 minus 0.84, which is 0.16. Again, I'm just kind of prepping myself for later because I know I'm going to need them. And if you don't believe me, 1 minus 0.84, 1 minus 0.92. Right? So that's where those come from. All right, so let's verify some conditions, shall we? So the first condition we need to verify is that it's random. It's the same conditions as when we run a hypothesis test. Confidence intervals has the same pieces: random, independent, independent population, and normal. All right, so we know it's random because it said so. It says the word random right there. So this is a yes given situation. Right? It was given in the setup. Now we need the new piece, right? We need independent samples. Well, that's fine. This is a yes because these are two separate groups of drivers measured once. You have to have both components, right? That they're two separate groups and they're measured one time for their seatbelt usage. This is the new piece, right? This is new to chapter 11. We didn't have this piece before. So that's the new component you need to add in. All right, what we did have before is independent of the population. That we've had. All right, this is going to be a yes, but I have to prove it. The way we prove this is little n is less than 0.05 of capital N. All right, so let me segment my paper a little bit here. All right, for the male group, I need little n for the men to be less than or equal to 0.05 capital N for the men. Okay, well, little n for the men, I wrote right here, it's 700. It's less than or equal to 0.05, and it'd be all male drivers. Because those are the two groups, right? The male drivers and the female drivers. Speaking of which, little n for the females has to be less than 0.05 of capital N for the females. And so that would be 600 is less than or equal to 0.05 of all female drivers. And these are both, of course they are, right? Like there are so many, 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 many male and female drivers. We're way below that with our 700, 600, so we're good. Now we need normal. Okay, well normal's going to be a yes, but we're going to have to prove it. It's n times p hat times q hat is greater than or equal to 10. So you see why I was finding the q hats up there. So I need n for the men times p hat for the men times q hat for the men to be greater than or equal to 10. So n was 700, p hat was 0.84, q hat was 0.16. So we're going to get a number, and it's going to be bigger than 10, hopefully. So let me go find that one. Okay, so 700 times 0.84 times 0.16 is 94.08. 94.08 is indeed bigger than 10. All right, so then we want to do it again for the women. It's n for the females times q, or times p hat, excuse me, p hat for the women times q hat for the women. And we want that to be greater than or equal to 10. So that would be 600 times 0.92 times 0.08. We get a number. It's going to be bigger than 10, but I'm going to prove it because I'm going to go grab Desmos. All right, 600 times 0.92 times 0.08, and we get 44.16, or 44.2. We don't really care about the rounding. All that we really care about is that it's bigger than 10, which it is. So we are good for both of these. These are both bigger than 10, and that's why it's a yes over here. All right, we verified our requirements. So what is this confidence interval? And what's the StatCrunch path we used? Well, the StatCrunch path is not hard to find. It actually says what the StatCrunch path is right here. Stat, proportion stat, two sample with summary. Same as when we run a hypothesis test. Okay, but when we put them in, we're going to need to put in the number of successes. I'm just going to label these up here. Right? This is x. X is the number of successes, and n is the number of observations. So when we go into StatCrunch and it asks for those, that's what it's looking for. Technically both of these. All right, so let's go in and grab StatCrunch. Stat, proportion stat, two sample with summary. X for group 1 was 588 and 700, and then 552 and 600. We don't want a hypothesis test. We want to click on confidence interval because that's what we're trying to do. And we want to change it to a 90% and then say compute. Now, if you want a confidence interval plot, you can, but it's not required. All right, so I'm going to say compute. I did it just for fun. And you might have to make your window bigger. That's okay. So there we have it. We have a negative 0.1092 and a negative 0.0508. So those are our lower and upper. So I just kind of wrote those in on my paper. And I'm also going to write my StatCrunch path, which was stat, proportion stat, two sample, because these are two groups, separate groups, measured ones, two sample with summary. And this is our result. All right, so now let's interpret that. Well, we've had a script for interpreting for quite some time, right? And the script is still the same. It's just that the parameter is different. So if we look back at our chapter 9 flowchart, we are this percent confident that the true population parameter. Okay, so back in chapter 9, that could only be a proportion or a mean. But now it can be a difference in means. Same idea though. We are still, in this case, 90% confident that the true, in chapter 9 it would have been mean or proportion, but in this case it's the difference in the proportion or proportions, actually proportion, difference in proportion of female and male drivers, male and female drivers that use seatbelts. Right, because that's what it was about. That's the hardest part, is to get that context. Right? What was it about? It was the difference in proportions of what? The proportions of male and female drivers using seatbelts. I guess it is proportions, now that I'm saying it. Proportions of male and female drivers using seatbelt is between the low number, and you can just write it as a decimal, or you can change it to a percent, whichever way you like it. So I'm going to change it to a percent, negative 10.92% and negative 5.08%. But again, if you want to leave them as decimals, that's fine. Percents are just a little bit more fluid for when we're speaking English. All right, so it's the difference in proportions. That part has to be there. And then all of this piece is really the context, right? Proportions of what? What were we talking about, right? So that's all that is, right? But the rest of it is pretty much the same as it was back in chapter 9. All right, so the CDC claims that the proportion of seatbelt usage is different, there's that word, different, for male and female drivers. Excuse me, male and female adults in the US. Does this interval support that claim? Okay, well, think about the picture. So you have your lower number at negative 0.1092 and your higher number at negative 0.0508. And you're 90% confident that it's somewhere in there, the true difference in proportions. Now, what's not between those two numbers is 0, right? 0 is not between two negative numbers. 0 is over here. So 0 is not contained in our interval. So there's no way it's this one that says 0 is contained in the interval. That's not true. 0 is contained. That's not true. So it's one of these two. All right, but remember, the null hypothesis is that when you subtract the two, you get 0, means there's no difference. If you have 0, there's no difference, no change. But we don't have 0, so there is a difference. It's this one. 0 is not contained in the interval, so there is a significant difference in the two groups.